Welcome, everyone. Thank you for attending my talk. The talk is called The Floor is Lava, and it's about a journey, I guess, over the past year and a half of trying to teach C++ and trying to figure out what to teach and what not to teach. And I tend to get a little bit meta, and this talk kind of goes into all of my neuroses, I guess, around this. So if you tend to go to my talks, they often have lots of pictures and lots of graffiti and things like that. This talk will have none of that. And the reason for that is that I decided to do it in Reveal.js. And I'm not really good at Reveal.js, but I needed to do data visualization. So hopefully everything will work. So, for people who are not familiar, The Floor is Lava is a children's game. I don't know if you have it in all of your countries, but it's basically you pretend that the floor is lava, and then you kind of jump from place to place. And the idea here is, do we have enough safe places to jump in C++ for it to be possible for a beginner to not fall into lava? So about a year and a half ago, I DM'd Quentin Jabot, and I asked him, so do you want to make a training teaching C++? I think he has regretted it multiple times since. He is absolutely brilliant. He's in the French national body. He is currently in the Hawaii on vacation after the standardization meeting. He is a Clang maintainer, and so he's the one that knows C++ really well. I'm really good at emulating being the student. So we made two trainings. The first one is called Mod C++ Fundamentals. And the idea of this one was that we were going to teach people who didn't know any C++, but they knew how to program. So we're thinking people who know Java, C#, something like that, and then we're going to try to teach them C++. But it's going to be just 2 days. So it became a question of what are we going to teach them and how are we going to teach them. And so the whole training is based around a game because we wanted to make something non-trivial and something that wasn't finished, and so they would have plenty of opportunities to do stuff. But at the same time, it's only 2 days, and you can only cover so much. And for most of you, you know that learning C++ is more like a lifetime process than something you do in 2 days, right? So the question becomes, how do we do that? And then we followed up this, and we made another 2-day training, which is called C++ Intermediate, and that was kind of thinking, okay, you know C++, ish. You've had some experience. You've been working with it for a while. Okay, let's level you up a little bit. So both of these trainings are not advanced trainings. They are for the absolute beginner and then like someone who wants to get to the intermediate stage. So the question then became, slowly but surely over like this period of time, that how do you teach a programming language when the floor is lava, when there's so many things that you don't want to teach. There's so many things that you don't want your students to do, but at the same time, they have to be able to code, right? So trying to find your way in this landscape became sort of like a problem I kept thinking about. And the thing is, then it comes to the question, do we even know what is lava? And I will use the word lava all the time. And we will get to it. I made many polls, and I used the word lava, and I have never defined what lava is. And I am not going to define it to you either. So my theory is that you know in your heart what is lava. When you look at C++, and I can show you a couple of things, you will be able to say that is definitely lava, and that is definitely not lava. And so what I'm going for here is kind of a community gut feeling about where we want to go. But the thing is, do we even know what is lava? So if we take a bunch of features in C++, and these are features in C++, like, look, I played. I was working on this talk, and my son comes to me, and he goes, "Mommy, can I play with your game?" And I was like, "No, it's not a game. It's a serious work thing." And he goes like, "Okay, Mommy, can I play with your serious work thing?" And I was like, "Okay." And then he starts going, and he was like, "Mommy." I was like, "Yeah?" I was like, "It has collision detection." And I was like, "Yeah, Mommy, it's a game." So this is my game. But again, so we can take lots of features in C++, and then we can color them for Lava, right? So now we have, like, some things are Lava, some things are definitely not Lava, but does it really get us to where we want to go? And I kind of concluded that it wasn't enough just to say this is Lava and this is not Lava, because a lot of things that are not Lava are not beginner material. And then I was wondering, maybe there are some Lava things that you actually need to know. So this became also like a meta problem. So what if all of the Lava is actually just anti-patterns and you should never do them? Like maybe all of the Lava in the language are just stuff you shouldn't do. You know, that's possible. Maybe this is like stuff that is deprecated, is still in the language, it still compiles, but you should not do that. And then if that's true, then you can just skip it. We can just pretend it's not there and just like, we'll teach the other stuff, the good things. Or maybe the Lava is only for advanced, specialized use cases, like not my job, like somebody else's job, like somebody who works on a compiler or in the standard library or something. And basically, who knows what std launder does anyway? Right? Okay, one person, two people. And what is subsumption? Right? Ah, there you go. But who really needs to know? Maybe there's a ton of things in this language that we don't actually need to know. And then it doesn't really matter if it's Lava or if it's not Lava, because it's not for us. But the hope is, and I think as a community we have wanted to believe that there is a modern subset of C++ that is safe, for some value of safe, right? We want to believe that it is possible to whittle down C++ to a little bit of a bubble, and within that bubble we are relatively okay. And if we just stay inside of that bubble, we're good. And I think every single company tries to do this to a certain extent, or even down to a team level. We're saying, in this team, we don't do std launder. You know what I mean? you set limits for what is too advanced or too dangerous for us. But for teaching, this becomes an issue, because C++ is vast. And if I'm going to teach, I'm teaching lots of people from different companies. And what am I going to pick into my subset? And the thing is, if you're going to teach an introduction to C++, then you have to choose. You have to choose because you only have a limited amount of time. And whatever you choose, like that, what they learn in the beginning is going to be what they're going to base everything on, that they learn from now on. So it should be solid. And that is super important for their own learning, to make future things make sense. But it is also because they will be somebody's colleague one day. Somebody will have to deal with the code that they produce. And not only that, they will have to deal with the feedback on the code that they write. And I want that to be a good experience. I don't want them to go and try to write C++ and get really bad feedback. I want, even if what they write is very simple, I want people to say, yeah, okay, that's good. You know, it's fine. It's not a problem. And in C++, it's really, really easy to, like we tend to call it, shoot yourself in the foot. And the thing is, the people that I'm teaching, they don't know any C++ at all. And they're coming from some kind of background. And they're going to try to map the concepts from that background. And depending on that background, that will make things easier or harder. But they need to learn enough, like in those 2 days, remember. In those 2 days, I have to teach them enough so that they can be productive, like they can actually go and write code that will run. So it's not a theoretical concept. I need them to have, and that suddenly requires a great deal of things. You have to be able to compile. You have to be able to understand error messages, right? You have to be able to add functions, add files to the compilation. You have to be able to navigate the code base. You have to understand the code that is there. Suddenly, it becomes a lot to cover in 2 days. And so we can try to, do this as an exercise. We're going to draw some lines in the sand, and we're just going to define. This is the minimum viable subset of C++. Given this, you can program C++. And it might not be the optimal. It might not be what your intermediate colleague or your advanced colleague can do, but it will be something that works. But how do we define that? Because, these are great ideals, but how do we go about trying to suss these things out? So we have to have some criteria. We have to decide what is going to be the selection criteria for the features and the language and the processes that we use. So I decided on 3. So the first one was it should be mostly harmless. So this is basically saying that if we're going to pick a feature, we want it to not have sharp edges if we can avoid it. So sometimes you just can't avoid it and you just have to go there, but we're going to try not to have any of those. So mostly harmless. It has to be useful. There's no point in teaching something that is something you will never use in real life just because it's not lava. It's a useless exercise. So teach things that are actually useful and they will have a use for in their jobs. So that they get skills that they need so that they can become productive. We have limited time. There's no reason to waste it on silliness. But it also has to be relevant to their current level. So when they are at work, these are people who don't know any C++, so they're going to be juniors in their teams. So they're not going to be the one that is going to be tasked with, hopefully, with version 2.0 of their internal standard library. That's not what these people are going to be doing. Most likely, they're going to make small changes in existing code, maybe make something simple, right? So they don't have to learn very complicated niche things because they're not going to be tasked with doing very complicated niche things, hopefully. And C++ has a culture, but I would say every programming language has a culture, and this is something that I've spoken about before in previous talks, and I don't think we appreciate it enough. So one time, many years ago, I had a colleague, and he was programming in a new programming language. I don't even remember what it was. And I asked him, how did you learn? And he said, I read the grammar, and then I started programming. And at the time, I was like, whoa, that was very impressive. Now, I think that's a mistake we make, that we think that's enough. But if you have ever tried to just sit down and write Python and then show it to a Python programmer, they are invisible pain, right? It's like Python programmers. It's like you can see they're hurting, and that is something that and people will use like fancy words for it, and they'll go like, this is not idiomatic Python. And I have figured out what they mean by that. That means you have an accent in this code. I have accents in code. I once upon a time tried to write Perl. Perl programmers looked at it and goes, Patricia, what is this? And I go like, don't hurt me, but it works. And they were like, it looks like C. And I'm like, yes, but I know C. So I had a strong C accent in Perl. I've seen Java code written by C++ programmers, very strong C++ accent in the Java code. And we do that. We bring the culture we know and the programming paradigms and how we do things, we bring them to a new language, and it shows, right? So if we're going to teach C++, then we have to try to integrate them into the culture as well. And the culture in C++ isn't necessarily well-defined, but it does exist. And so there is no definite list on what the sharp edges in C++ are. Some people have been trying to catalog at least parts of it, like Shafiq Yamor has been trying to catalog all of the undefined behavior in the world. But there is no definite list of these are the bad things, right? But I think we kind of know. So that's what I was kind of hoping when I started this, that I could figure out by asking in the community, I could try to figure out through our kind of collective consciousness what this is. And of course, I did this in the traditional C++ way, through Twitter polls. So in this talk, all of my visualizations is based on massage data, which was gathered from Twitter polls for science, right? I had thousands of replies on these Twitter polls. It was insane. I spammed everybody's feed. I think half of the C++ community probably, that hadn't already muted me, probably did at this point. But we did learn things. There was value from the pain. So if any of you ever voted in any of these Twitter polls, this is the result. So because we have this data, of course, it must be visualized, and therefore this type of talk. So this is Reveal.js, and underneath I'm using D3, which is a JavaScript framework for doing data visualization. So I'm going to try to visualize things in different ways. So the lava is going to be the representation of like the harmlessness aspect. So we have not lava, leads to lava, and lava. Then we can do the categorization, we can color up all of the features, but it's not enough, right? So we have to figure out how useful it is. So I've split this up into what is necessary, so things you absolutely need to know to be productive. What is useful, so things are good to know, it's going to help you. Well-rounded is like, we're getting into a little bit of an esoteric knowledge here, but it's good to know you're probably going to use it occasionally. And then you have specialized, and it's most people won't need it, right? But at the same time, what is considered to be necessary or well-rounded will depend on what level you're at. And so if you are an absolute beginner, what is necessary to know as a beginner will be different from what it is when you're an intermediate or advanced, right? So we can put all of these things together. So we're going to use the two axes for this beginner, intermediate, and advanced, and then necessary, useful, well-rounded, and specialized. And then we're going to use color for lava. And hopefully, combining these things together will give us some knowledge or more questions, possibly both. So we can take these wonderful C++ features, and then we can color for lava. Then we can try to rank them by utility. So up here at the top, let's see if I can point. Yeah, so up here at the top, we had the necessary stuff. And down here at the bottom, we have the specialized stuff. So what we can tell just by looking at this is that there's a lot of green in the necessary portion, very little lava actually, which was interesting. And the lava is very bottom heavy. So it's very much like specialized knowledge, and you might not actually need to know a lot of lava or use it in your day-to-day job. Okay, but we rank by utility, but let's do group it by level. So on the left-hand side here, we have the beginners. And it's still spread out. So what we can see with the beginners is that a lot of the knowledge that we expect them to gain is very much in the necessary and useful categories. So by the time you kind of graduate through the necessary and useful categories, you're probably going to be moving over to like an intermediate level. And what we can see with the intermediate level, the middle bit here, is that it's a little bit more like, you know, there's still a lot of things that are not lava, but there are some lava things, and there's a lot of things that lead to lava. And then when we look at advanced, it's basically all specialized knowledge. And this probably will fit with your experience from your companies, is that you will have a few people in your company that know like the really deep, nitty-gritty, weird stuff. And you probably don't need more than a few. And whenever something gets really, really tricky, you go and ask one of those people, and they will work for 2 weeks and commit 2 lines of code. But they will be 2 lines you could have never written, you know? So back again to never like use lines of code written to measure value, right? They will write a very long commit message, though. So, so let's look at what is in this, because so far I'm kind of just treated these as bubbles and process them this way, but let's see what these bubbles actually contain. So before I do that, let's note the interesting features. It's mostly not lava, and it's mostly necessary and useful. So I'll read these, but I won't do it for intermediate and advanced. I'll probably just mention a few. Okay, so these are from the polls. So we have IOStream, pass parameter by reference, pragma once, asan, auto, C-style for loops, Clang format, Clang tidy, class, const, debuggers, enum class, equals default, heap allocation, includes, inline, iterators, lambda capture, ref, previous talk, lambdas, msan, namespaces, object-oriented programming, package manager, pass parameter by const reference, pass parameter by value, references, return by value, short-circuit Boolean expressions, sign integer addition and multiplication, stack allocation, std array, std optional, std size, std string, std unique pointer, std vector, STL algorithms, string literals with no suffix, struct, and ubisan, and values, and warnings. So this is kind of the chunk that people ended up like pushing up into that corner. What is beginner and what is necessary? I'm going to think more about this later in the talk, but I'll just list up the rest. So it gets a little bit more. So this is where we get to useful. I think some of these things will change. So one of the things that we have, let's see here, is the FMT library is here. But as we get a std print, a std format, and people start using it, then I think it will disappear, but that will come up here. Some things that here you have import, and I think also maybe as we are starting to use modules more, then that probably will change. I also like the fact that some things people just decide, it's like sign integer. There was a lot of discussion about sign integer. Is it bad or is it not bad? And people are like, you just have to use it. So there are lots of things here that are actually controversial. Here, for example, pragma once, and I'll talk about that later as well, is non-standard. But it's still here, right? So even if we have kind of split this up, it doesn't necessarily bring us where we need to go. One of the things I want to point out, of course, is that this bottom thing right down here, this is the specialized knowledge. And specialized is empty for beginner. So it basically means that, by the time you've gotten to this point, you are moving on to intermediate, and you don't need specialized knowledge in the beginner stage of your learning, which kind of makes sense. Okay, so let's look at what is intermediate. And this is a mixed bag, because it has a lot of different things, and it's also spread out through the utility ranks here. So, but it's already leaning towards specialized. Let's see, I think I have to use the keyboard for this, just to fill it in so we can talk about it. Ooh, no. Here we go. All right. So already, if you want to be a beginner intermediate, if you want to, the necessary qualifications for being an intermediate is having an understanding of globals, undefined behavior, new and delete, CMake, one definition rule, and static. And then it kind of goes more and more towards C. So you can find here, so this is the specialized knowledge for intermediate. It's a lot of C stuff. We're also getting into concurrency and shared pointers here. So it's interesting. I can see how this would be intermediate. When we get to advanced, it starts getting weird. So the first notice here, as opposed to the beginner, advanced does not have a necessary useful, like everything here is either well-rounded or specialized. Like if you're in the advanced category, the knowledge that you have added is weird stuff, right? Or the first here, the well-rounded is not so weird. You have stood forward, which is a little bit weird, but it's not too weird. But then we get to like the icky parts, like ABI and flexible array member, which made lots of people, it's non-standard, Patricia. Stood auto pointer, it's deprecated. Stood launder, who knows, Okay, who knows what stood launder does? Okay, so 2 hands and 2 people going like this. Okay, okay, who have used it in production code? 1 person. Okay, so probably not like super necessary for your job. Knowing that the stood vector bool is a thing is apparently considered to be specialized esoteric knowledge, which is probably fair, I guess. Union. Variable length array is here. Enable shared from this. Which Olafur was like, what? People don't know that? Yeah, placement new, pointer provenance. That's like a thing that standard library writers talk about. Spine, address of, decal val array, strict aliasing rules, subsumption. Trivially movable or copyable, and type traits. Okay, so most likely, a lot of these things are not familiar to you, unless you are like of the very few people who do these kinds of things. Many of them, maybe you've heard of them, but you've never actually used them or know what they are for. So the good thing is, I can tell you, you probably don't need to. So these are things that are relevant if you work on the standard library, probably, or if you work in some kind of similar capacity. But for straight-up normal application programmers, you probably will never use any of this, or well, some of this. But the thing that got a little bit meta about this Twitter polls. So for people who haven't made a lot of Twitter polls, what you want is people to vote for what they think. But a lot of people don't know, and so when they don't know, if you don't have an option for them to see the answers, they're just going to vote for random stuff. right? So I didn't want that in my data. I wanted people to vote lava leads to lava, not lava, right? So to get away from this, I added an option, show the results. And that's just basically so that people who are curious can see the results without skewing my data. That was the plan. Turns out that show the results became its own information channel that wasn't intended. And I called that what. And that's when people were like, is it lava? And they were like, I don't know what it is. I cannot tell you if it's lava. And so some of the most what answers that show me the results won by a gigantic margin. Like for some of these, like 85% voted for show me the results. so the large majority of the community had no idea what this thing was, and they did not know if it was lava or not. So then I tried a different visualization. So here, the size of the ball is determined by how many people asked, show me the results. So how many people went, what? I don't know. What is that? And so you can see that it's very unevenly distributed. Like some things people were very, it's like, oh yes, this is good, this is bad. They had a very strong opinion. And for some of these people, I don't know, I'm not sure what it is, maybe it's good. So what are like the top 3 whats? So I've mentioned a couple already. So subsumption, stood launder, and flexible array member were the biggest whats. But then it's also interesting to see what is the least what. Like, what are the features that people were the most comfortable having an opinion on? So we have debuggers, overloading, undefined behavior, manual memory management, C, hash define, globals, struct, namespaces, pointer arithmetic, and bitwise operations. And these were things that people were like, I can confidently have an opinion on these things. And they are varying things. Some of them were like lava, some of them were not lava, but people felt confident that I know what it is and I have an opinion. And that's also kind of important, I think, because if we don't, as a lot of these people who were voting have been programming in C++ for a long time, if you don't know what something is, it might not be that important. So that also became a thing that I started to wonder if that was actually a weight I should consider. Okay, so then I tried a different way of visualizing things. And so I call this the atlas. And so here I'm trying to pull all my little balls into different corners. And so I'll show you on the next slide, and then I'll go back so you kind of understand what it does. Okay, so like that. So now I spread them all into different places, and I'm going to go back to show you what these places mean. So on the left-hand side, you have a lot of like C features. So we have like C, we have pointers, manual memory management, macros, UV, casts. You also have the console, like writing to the console, which has been, tricky in our history. And then we have, smart pointers, which are kind of like vaguely related here to manual memory management. In the middle, we have C++ is like slam in the middle, and this is, when I say C++, here is language features. So not the standard library, but language features. And then when I say parameters on top, that's both parameter passing and return values. And on the bottom, I say threads, but it's like anything concurrency, right? On the top right part, that's compile time programming, templates, template meta programming, and then, of course, the standard library. And then in the middle there, we have object-oriented programming and containers. And then in the bottom right corner, we have build tools and other types of tools. So sanitizers, linkers, any kind of Clang format, those types of things that we use. So if we take all of the things that the beginners are supposed to know, that we want to teach them, then they kind of spread out like this. And one thing that is interesting to see is that on the left-hand side here, where we had all of the C things, there's very little. We don't actually want to teach C, apparently, as a community, which all credit to Kate Gregory, who had stopped teaching C talk many years ago. And there's a strong focus on learning language features and how to do parameter passing. So it's very heavy in the middle here, and a lot down in tools. And this kind of makes sense. We want them to be able to write programs, right? And so we're thinking more application programming, and they have to be able to build. They probably need dependencies, and now we have actually like 2 contenders for dependency managers. We have like 10, but like 2 big ones. And so this is the kind of spread, but you also have up here in the standard library and down here in containers, but this is mostly to use the standard library and use containers, right? Okay, so the full atlas, when you take in everything, it looks like this. So this is all of the features, but spread out in the same kind of grouping. And what we can see is a lot of what we consider to be lava is in like the C adjacent territory. And there's, the most of the rest of it is green. So that's quite interesting. And especially down here in tools, I was expecting people to be more skeptical, but people seem to be very happy and encouraging in people using more tools. So if we go back to the beginners are not supposed to learn much on the left-hand side here. We don't want to show them our nastiness right away. Like this is like we're hiding our things for our beginners. But at a certain point, you have to learn. And so, let's see, we'll do it like this. So here we have the intermediate. So now we've gotten past you've been like starting off as a programmer for a while, and now you're getting the more complicated tasks. So what are people expecting you to learn? And it's definitely now filling in on the C stuff. And by now, people expect you to already know all of this stuff, like all of the tools and all of those things, how to make classes. There's most of this they expect you to know already. And it's filling into what you are supposed to learn about templates. So now you're getting to maybe you have to understand how to read them and write simpler templates. And they kind of, by now, expect you to know most of the language, but you have now concurrency becomes a thing that you might become responsible for. And then we go to advanced, or let's do this so you get the wonderful animation. There you go. So when you come to advanced, it's basically we're just teaching you the rest of the lava. Like the stuff that you didn't do in intermediate, we're just going to go there with all of these things, which I'm sure this one over here is probably stood longer, right? And the good thing, I think, from all of this, because okay, so I've visualized this in many different ways, and what I'm trying to find out is are there any insights? Basically, do we know something as a community that we can use to narrow down what to teach? And there seems to be an area of C++ that we feel is appropriate for beginners, and that is mostly not lava. So that's a good thing. But the thing is that the one that I kept coming back to, because we didn't have enough categories to classify the data, so I have to make it more complicated. Is it enough Because one of the things that I started worrying about is that we don't want to teach some things that we think are icky, but that they actually need to know. And there are specifically two different situations in teaching that, that made me think about this. Because we have to have the rules. So the rules for the training, and I was very strict in enforcing the rules when we were making the training, nothing is magic. If we teach it, they have to understand how it works. So I don't want people to go like, I don't know, I just, like, okay, so one thing I've heard lots of people do, like in the beginning where they don't understand like pointers, they go like, no, I just put in more stars and more refs until it works. It's true. But the thing is, I don't want that. You know, I don't want there to be magic. And so the rule in the training was, if you can't use it if you don't teach it. So nothing in the code base, nothing on the slides, nothing. We couldn't talk about anything if we didn't teach it so that they understood what it means. And this can make, it creates an interesting restriction. But it also meant that some things we had to put in because we had to explain it, or else there would be magic. So the first one is inline and ODR. So first round, we did not teach inline and ODR. And now if we go to the data, the community also says that one definition rules is intermediate level. We don't expect beginners to know about one definition rule. Interestingly enough, inline is classified as beginner. And the thing is, we didn't teach it. First version of the training, we didn't teach inline, we didn't teach ODR. What happened in the training was that they had to write a function. They wrote it in the header file, and then it didn't link. And then they go, why doesn't it link? And then somebody said, I put an inline there, and now it works. and that becomes a problem, because back to the thing, it's nothing is magic, right? You can't use it if you don't teach it. And so we actually went, and I think I have it here. This is like just one out of many slides where we tried to explain ODR. And none of us wanted to do this, but we could have maybe gotten away with it in the training itself if std_abs was const expr in C++ 20. Which it is not. It is in C++ 23, and we were not using C++ 23, and so and one of the functions that they had to do had a std_abs, so they couldn't use const expr on it, and then suddenly we were having to say you have to use inline, and what does inline do? Well, it definitely doesn't necessarily do any inlining, which is great. It's like static. It's like we have a keyword, we're just going to use it. You know, C++ 26 is coming. We can do co-static. It's still open, you know? Anyway, okay, so back to this. So we ended up teaching inline and ODR, even though we didn't want to. And so that becomes back again to the problem of is it enough? Like maybe we as a community want to pretend that this subset exists much more than it actually exists. And maybe we're not aware of where we're actually pulling in complexity for beginners because we haven't really thought about it. Because as intermediate or advanced people, we know these things, so we don't think about them. Another thing, and I kind of touched on it earlier, is header guards versus pragma ones. So pragma ones is non-standard, but basically supported in pretty much every compiler, right? Header guards, that is like the standard way to do things. The thing is, if I'm going to teach you header guards, what do I have to teach you? I have to teach you define. I have to teach you if-defs. Suddenly, I have to teach you macros, right? I could keep the preprocessor out of this to a certain extent by just saying, oh no, the preprocessor is the thing that resolves your includes, right? And it has this pragma fanciness. And I don't have to talk about it any more than that. But the moment we introduce header guards, suddenly we have to talk about macros and if-defs and all of those things. I don't want to teach that. So, no header guards. Teaching pragma once, from the beginning. And if you look at it from the results, the community agrees. The community says pragma once is beginner, header guards is intermediate, together with macros. Which actually means that right now, the community as a whole, we seem to agree that the non-standard way is the way that we should be teaching, which is interesting. Okay. So let's go back to the beginner, because the beginner, I separated, so we have, this is our student, hopefully going through learning the necessary, the useful, the well-rounded, and the specialized. And we figured out that there is no specialized knowledge for beginners. And almost everything is up there and necessary and useful. So this is the beginner. But what if we just take the necessary parts of beginner? So this is a quite small set, and we looked at it earlier. And I'll put it up again so you can see it. That's going to be my ending slide in a second. But this doesn't look half bad. I think what it needs is I wanted to say well-roundedness, but I've already used that term. You need to make sure it is complete, because you need to have teach enough features for someone to be able to program. And I think we try to skip some things because we don't want to talk about it, like ODR, right? Or like inline. But the thing is, a beginner student is going to do these things. They're going to get a linker error, poor souls, and they have barely heard the word linker. So you will have to add things even if you don't want to, just to make sure that they understand what they're doing with the little subset that they're working with. So based on all of our Twitter polls, this is what we teach when the floor is lava. So that was my talk. Thank you so much. So we have lots of time for questions, and I'm sure there are questions. People are taking pictures. Okay, I will walk away. So there you go. It's a good thing you're taking pictures because I still haven't figured out how to make the PDF. Apparently, I can just add PDF at the end of the URL. I'm not sure. Yes, questions? Yes?
Yes. So a lot of the really advanced stuff is C.
Yeah.
And this is about teaching people coming from another language.
Yes.
So the people coming from C, if you had a class specifically aimed at people coming from C to C++, would you change the scope of what is Lava and what is advanced?
Actually, I think I wouldn't, and maybe even more, because that's the problem. And like I think right now, if you're going to learn the type of C++ that is kind of being considered to be like good right now, coming from C is going to be, in many cases, a disadvantage. So it's funny that I think right now, if you were coming to modern C++, like post C++ 20 with ranges, and modules and things like that. If you're coming from Kotlin, you're probably better off. and that's really hard, and because we don't want you to do manual memory management. So knowing manual memory management and being good at it is not an advantage. It means that you are probably overthinking things and being too concerned by doing something really efficient. So I would say just pretend you don't know any C. And now we're going to do this. This is how you are not allowed, and that's one of the things in the project. There's not a single pointer. They get a project, it's a game, it's a Pac-Man game. You can walk around in it, it's controlled by arrow keys. There's not a single pointer in the entire project. There's not a single new or delete in the entire project. And they're not allowed to do it. And so bringing people into that and saying, okay, it is a constructed environment in a teaching situation. But to say, you are not allowed to do these things. No pointers for you, no malloc, no free, no new, no delete. I don't want even a shared pointer in there. Go. Right? And it's going to be different. In my experience, also, C programmers might get a little bit annoyed. But we're trying to teach C++. And then we just have to be honest about that what C++ is trying to be is not C with classes. Yeah. Did that answer your question?
Yes.
Okay, thank you. Yes, go.
Oh, okay. I've seen a lot of people being confused by what are L values, and things like that in C++. And based on what you said, it's something that you can easily have in the error message. So if nothing is magic, did you teach that also? And I think it doesn't appear as a language feature in your presentation.
No. Std move and L value and R value, we teach it in the intermediate class. And I think probably that's necessary because one of the things that is hard, even when you take away manual memory management in C++, so we've taken that away. That's one of the really hard things. We've taken away all the pointers, very, very hard for most people to understand. But we have this concept of copy semantics, and that is very fundamental to how C++ works. And to understand move semantics, you basically have to understand copy semantics. And copy semantics and dealing with values can be very difficult if you're coming from language which has like basic types and everything is a reference. And so I think bringing R value references into that is just too difficult. So I think you have to have a solid understanding of what a reference is and what a const reference is and what a value is, and it's only once you have that solidified that you can actually move. You can actually go over to learning, move. Does that make sense? That's my opinion, at least.
Yeah. So you have to draw a line between. Something will still be magic. You can have this error. But
No. Basically, it's that there's no move for you. Everything is copy. And then when you get to that point, then you go like, oh, so I don't have to copy. And then suddenly, the world opens up for you. But until then, you can live in a mental model that everything is a copy. And that works. And then later on, they get to a point where like, oh, okay, when they want to level up, then we can get into that. But even in move semantics can get very complicated. The book is almost 300 pages long. So it's non-trivial. So you still have to cut that down even for intermediate. So I would say understanding deeply and fully move semantics is advanced. And I would say probably even like Std forward is advanced. So it's a topic that kind of goes across.
May I ask another question?
Yeah.
What version of C++ was the tweetables based on? Did you stop at 17 or higher?
No, so I didn't say. at the time. So, but I did it now it was in August, I guess. C++ 20, I would say, was I don't think anybody cared about C++ 23 at that time, outside of the committee, sorry. Apologies.
I'm wondering if you had another category to categorize every feature by what version of C++ is, what would be the result? Like maybe everything in C++ 20 is lava, I don't know. That may be interesting.
So one of the things that is interesting is that you saw some things being categorized as more specialized knowledge that probably will end up being not that. Like one of the things that, let's see, I have to go back. Okay, give me a second, I can go back. Here. Does that work? Okay. So some things here I found interesting. So here, for example, you have null pointer. So for some reason, we think it's fine that null pointer is something we want to teach to beginners, but we're not going to teach them pointers. So which is again like a thing where I feel like people, like don't categorize on things you like and things you don't like. Categorize on what is useful for this kind of person. And so, but also here you have import here, whereas probably if and when we get used to working with modules, import is probably going to be a necessary thing for beginners to understand. I don't remember exactly what your question was.
It was maybe more a suggestion or a remark that I would be interested if some days we also categorized by C++ version of, or if maybe, like you said, this will evolve with.
Yeah, I think we will evolve as we change how we program. We will evolve. Some things, like for example, we don't have a shared pointer here, whereas I think if you'd asked this question like 5 years ago or something, people would put shared pointer in here. But now shared pointer is considered to be very advanced and should only be used in certain specific cases. But we didn't necessarily have that community knowledge 5 years ago. So I think we also change over time as we have experience.
Yeah. Thank you.
Yeah.
Is this on? Oh.
Yes.
I want to tie this a bit to Nico's keynote this morning and ask about your experience in teaching a beginner course about const shallowness, const propagation. How is this topic surfacing on the radar in your trainings? Do you find this difficult to convey? Do you avoid the topic? Can you avoid the topic? How do your students recover after finding out the details?
No, the thing is this is sort of like the fundamental issue here. You don't want to teach all the details. You want to teach enough so that people will have an intuition that is correct, even if they don't necessarily have like all of the details. They will have a correct intuition. Like one of the things that this is for the intermediate training. So I talked about subsumption, right? Me and Corentin, we spent like a whole day on subsumption. So this is a thing with concepts. And it is something you don't need to know, but we needed to understand it deeply to figure out how we're going to teach it. And so what we basically ended up with, we're going to teach it as an intuition. And so when it comes to constness, a lot of programming languages have some kind of idea around immutability. And they have an intuition around immutability. And there is a tradition in many programming languages to aspire to have immutability. And so it's generally fine to describe a const reference to being an immutable view or immutable access. I can't use the word view in C++ anymore, but to an object where you can only use the const parts of it, and it's just, and this is this is something that doesn't exist in other languages, but if you tell them that, they'll go like, oh, okay, so I can use that just as like the other one, except only the const things, and they were like, yes, because they're beginners. You want to give them an intuition and not necessarily like understanding, reading the standard. Did that answer the question?
Partially.
Partially.
I was interested a bit on exploring the shallowness of constant C++. And
No, I think okay. So this is one of the things that is with C++ is that you can have, this is a very specific thing to C++, you can have someone come pitch to a conference that they're going to do a 3-hour presentation on signed integers. Okay, this is, and not only will they get the talk accepted of 3 hours talking about signed integers, but the room will be packed. Okay, this does not happen in other programming languages. So there are so many corner cases to almost anything, and we have a tendency to nerd out in all of those corners, and that is not appropriate for teaching. They need to have, because then what am I going to do? Am I going to spend three hours of 2 days to talk about a niche topic that doesn't really matter? It's a waste of time, and they won't even understand it, and all I've done is scare them. So instead, I'm going to tell them, here are tools, right? I'm going to say, we're going to always have Clang Tidy integrated into our IDE, and it's going to say stuff to us, and it will have a little bubble and squiggly lines and fix-ups and all these things. We're going to be running our debug builds with address sanitizer on, and it's going to give you stack traces and the things, and it's going to tell you what's wrong. So instead of teaching them all of the scary corners, I'm going to give them tools that will give them better feedback. That's my personal opinion. Yeah.
Thanks.
Bye.
Hey, so first of all, great presentation, great use of data. Not very advanced myself, but it was super insightful. My question is kind of related to the last one. So you give the students some training, and then on their happy island, they will write good code, but that's not what happens, right? They go to the company, and the first 2 lines of code they write is not a standalone program. It's somewhere in the other code. And this is kind of like an overdose of caffeine, maybe, and then something doesn't work, and they go to Stack Overflow, and then it's like steroids, and they can't handle it. So shouldn't you give them like a no-no list as well? So don't use, I don't know, unsigned integer, macros, raw pointers, until you have a driver's license for that or something like that.
I think it's a little bit like telling people don't think about an elephant. Now it's everything, that's the only thing. So instead I'm teaching by omission, but I'm also telling them we're omitting things. And when they show up in their code base, they're going to see some things. We all have seen some things, and then they come. And so I've had a few rounds of students that have taken the fundamentals training. Then they've gone and been programmers in their teams, and they come back like 6 months later and do the intermediate training. And that's very interesting, because they were like, it's like I had a few people who came and they were in the Qt code base, and I did not teach them pointers, remember? And they come back and they're like, oh, there were pointers everywhere. And I was like, yeah, that's, but then they had to learn that, but they had a sense, or at least I hope, of what is considered to be modern C++. And that is an aesthetic. Again, back to what is idiomatic. What is the culture? What will people look at and think is pretty and not pretty? It's not about, can you make code that works? Can you make code that makes your colleagues not cringe? which is not a tool-supported thing, mostly. I guess Clang Tidy can cover some of that. So the point is, again, time is limited, right? So you have to choose what goes in, what goes out. And what you hope is that they're going to have a sense of what modern C++ looks like. that they have an aesthetic for it, if that makes sense.
Thanks a lot, yeah.
Yeah.
Thank you so much for this speech and for the data processing here. My question is maybe a little out of scope. There was a question about transitioning from C to C++, and you were also saying about bringing some accent from other languages, but is it actually possible to start with C++? So to start with this beginner non-lava part, or maybe it's not a good language at all for that, and you should start with some other.
Okay, so some people think it's possible. A lot of universities think it's possible. I don't think it's possible.
Including mine.
And the reason why I say I don't think it's possible is because just understanding programming as it is mind-blowing enough to just, I'm going to write words here, and then some execution is going to go through and jump around and do. There's so many mind-bendy things about just understanding programming in general. And then I'm going to throw like use after free at you. It's a little bit too much. I think so. So I think it's better to start with a higher or a safer language. But I would actually say go for a language that has more of a modern style to it. So for example, I mentioned Kotlin. I think Kotlin is great in that it will give you that stream, Java stream-like thing, which will help you with ranges. I think if you're coming with Kotlin and you're going to program modern C++, ranges is going to be much easier for you than it is for somebody coming from C, right? So it has to do with having a mental model for how one does this type of programming, and you can practice that in safer ways. Yeah.
Okay, thank you. Can I ask one more question? There were all these things that people chose for Lava, non-Lava, etc. And you also said that some of them have dependencies, like you can't include guards without telling about macros. So basically, it's an ordered graph, and probably all intermediate part must not, all beginner part must not depend on intermediate part, and probably there is also some dependency cycle. How do you work with that? Maybe there are some approaches.
It's hard. It's hard. You have to make these choices, like the fact that we suddenly decided we're going to teach ODR and we're going to teach inline, even though we didn't want to, and also the choice that we're going to do pragma once because we don't want to teach macros, and you kind of have to make those choices. We don't teach null pointer in the beginner training because why would they have a null pointer? Now, if I'm going to explain a null pointer, I have to explain pointers. I don't want to explain pointers, so we're not going to have a null pointer. So you have to make those kinds of choices. Yeah, but you're right. It's a graph, but I haven't tried to graph it. Yeah,
it's about excluding, right?
Yeah.
Hey. It's a really short one.
Okay, because he had 2 questions and he's been waiting a long time. Is it okay?
I'm going
One
to
question?
Really short, okay?
Yeah.
Okay, so thanks for collecting the data and for the nice animations. Now I'm wondering if you're still teaching this, or if you can book for teaching that, or is that an online course or something?
No, we teach mostly, we can teach it online, but we teach it for companies. So yeah, just reach out and we can book it for your company.
Thank you.
Yeah. Okay, there we go. Thank you.